Welcome to the San Diego Archicad Users Group Complete Archicad GDL Programming course. In this course, we're going to be covering the very basics of GDL all the way to advanced techniques. GDL stands for Geometric Description Language, and this is the language of Archicad. Using this language, you'll be able to create custom parametric objects and use them in all of your projects. You'll find that you can create objects that allow you to be much more efficient and save a lot of time. Let's get started. Now you're going to want to start by going to the first floor and bringing up the toolbar. So Window, Toolbars, Edit GDL Library, and go ahead and dock this up on top. Now we have a couple commands here, and I'm not going to go into all of them right now, but the first one you want to use is New Object. You click here, and this gets you into the programming interface. Now Archicad's a little unusual in its programming because it uses several different scripts to create the object. The first script is a master script. The master script covers all of the portions of the program that are comprehensive, that need to be evaluated if you're looking at the 2D or the 3D representation. The 2D script is specifically going to create the 2D representation of the symbol of your object. The 3D is going to create, obviously, the 3D element. The other scripts support this process and the interface that is created when using an object. Let's go back to the first floor and open up a relatively common object. We'll do the tub that is from the basic version, and here it is. If we select that, there's another button here on this toolbar, and that's Open Object. And you'll find that most objects you can actually open and evaluate. And this gives you a way to find out how the master programmers are creating objects. You'll see that this looks fairly sophisticated, maybe even a little overwhelming. But don't worry, you're going to find that all of these elements are pretty simple. And generally the objects that are created and distributed with Archicad are a little bit more complicated because they need to be used more generically across different platforms, and because they're trying to reuse different aspects of objects. For example, this object, the tub, is calling another routine that is the tap, and another routine that does this and that. So they're trying to reuse a lot of information because they're making hundreds of objects. You, on the other hand, can streamline this process, and you'll find in general the objects that you create are just as useful, but a lot less complicated to understand. But nonetheless, this is what an object looks like. Let's start at the top. This is the details, and this is an important screen. Now the subtype determines how Archicad is going to consider this object. Now flow equipment means that it has MEP elements embedded in the object. So this is not the standard object type that you would use. Now let's go find another object that's fairly common, maybe a chair. Here. And now we'll open this object. And notice this is under the subtype seating. So each one of these is a little different, and what's most important is that they want to be under model element, and if it's under a model element, then you're going to find that it's a placeable object. That's what's going to be important. Let's look at the object that we created by default. And this did take the subtype model element. So that's what the subtype's all about. First thing we want to do is make sure that the placeable button is checked. or we're not going to be able to place this in plan. Placeable means that the object is going to be able to be found when browsing. If it's not a placeable object, then this is an object that would be used, or the term is called, by other objects. For example, the tap that I described, where the faucet may be used in a lot of different objects, I'm not able to place that tap directly into an ArchiCAD file, but other objects can reference that file and use it. Author is simply your name or company. There are different types of license, and you can use public domain if you want. If you select this information bar, it's going to take you to a website that's going to give you a little insight into what those different licensing items mean. For practical purposes, it's not going to affect how your object is used. Here we have description, and then we have keywords that we can use to find that object. So it's very easy to set up your basic object and get started. Now we go into the Parameters tab. The Parameters tab is a collection of all the variables that are going to be available for the user to reference. So let's go through what these different variables mean. So the first three variables are always going to be included in all objects. It's the A variable, or the width, the B variable, the depth, and the ZZYZX, which is the height. So these are your three basic dimensions of any object. You don't have to use these, but it's strongly encouraged because ArchiCAD users are common. It's common for an ArchiCAD user to be looking for these variables. If you don't want them to show up, you can click on the X. Notice that you can reorder these variables. Little background on the ZZYZX. ZZYZX is actually a town, I believe, in California. And when one of the ArchiCAD programmers was on a trip to California, he came across the sign that had ZZYZX, got excited about it, and decided to include a variable named ZZYX. So that's where that came from. But for our purposes, this is just the height. Now you'll see that it's defaulting to this value, and this is exactly 1 meter. If you want to put in 1 foot or any other nominal dimension, go ahead and type that in there now, and this will be the base value used for your object. Now we have 3 other items here. These are currently not shown. This one determines if the 3D hotspots will show up in 2D. Currently it's on. I generally like to turn that off. Then we have the boundary element of an object, the top and the bottom level. And this is 0 and 1 currently. So these are our basic parameters. If we go to File, Save, and we're going to save this in the embedded library, and we're going to first object, go to the first floor, and now the first object is selectable, and you'll see that these are the values. This is the A value, the B value, the ZZYZX, or the height, and this is the distance that the element is offset from the 0. Well, now this is a funny little object because it can't be selected because there's no elements to be selected. we're going to go open this up. We're going to pull down this list here. We're going to go back, or we could have selected the tab. Now we're back into the first object. So these are our parameters. Notice that these parameters have different types. This is a length. This is a specific parameter type for A and B, and you won't be able to use those for any other items. But the other types of variables that we have are length, angle, a real number, an integer, a boolean, either on or off, true or false, text, pen, a line, a fill, a profile, a surface, a building material, and here's a couple of organizational items, a title, a separator line, and now we have a new type of variable called a dictionary variable. So these are the different variables that you can use. I'll create a text field, and this will be, we'll call this the name of the object. The variable name is shown here on the left. This is the actual name that will be referenced in code. Here is a description, and this will be shown when you look at the parameters. This is the default value. So now let's give ourselves something to look at. We're going to start by drawing a line from 0, 0 to A, comma, B. There are errors in the script. So we can check the script, and it tells us that there are too many parameters in line 2. We'll stop. So what happened was I forgot to put in the number 2 into the command. The command is not called line, it's called line 2. Now it's showing that the script is okay. So I did that in an effort to show you that it's okay to make mistakes and you're going to get feedback. And you don't even have to understand this line right now. But what I want to show you is if I hit Control S or save, and I go back here, I have 2 instances of this object that I didn't even realize I placed. So here it is going from 0, 0 to A and B. Let's try changing this to 6 by 2. You'll notice with one command, we have already created our first object in ArchiCAD. You'll also notice that we have some graphical editing available to us. So ArchiCAD's giving us boundary hotspots, and by manipulating these boundary hotspots, we're actually able to adjust the parameters A and B for dimension 1 and dimension 2. Pretty easy. Let's go back to our object and look at the details. You'll see here it's dimension 1 and dimension 2. We could call this something width and depth. Hit save, Control S, back. I select this. It didn't actually change the description here, but if we select the parameters, we do see that there's an object called, or a variable called name, and here we can do name of object. So it looks like the dimensions names are always going to be dimension 1 and dimension 2, regardless of what we call them here. That's good information. So now that starts us off in our first object. And now instead of making a line diagonally, let's talk about the line command. Now the line command, line 2, because it's a 2D line, has x coordinate and a y coordinate for the start point, and an x coordinate and the y coordinate for the end point. So instead of going diagonally, let's make 4 lines. Control S for save. And now we've created a rectangle with dimensions 1 and 2, or A and B. And you'll see how easy that was to create. So let's talk a little bit about how do we know what commands to use. So there's a couple of references that you're going to want to find. The first is the PDF guide GDL reference. And this is the reference that comes with ArchiCAD. This particular version is 700 pages. And I highly, highly recommend that you spend the money and have this printed by a local print shop. I generally have it broken up into 2 or 3 volumes so that I can have the print shop put in a black spiral binding, and I find that about 125 double-sided pages works well in about a 3/4 inch spiral. And this way I have reference, and I find that if I have it written, I can page through things and find new ways to do things much easier than perusing through a PDF file. Now, I do use the PDF file in conjunction because the PDF file allows me to do searching. So I use both the PDF and the printed version. Now, another reference that I highly recommend is the GDL Cookbook. And I will place a copy of the GDL Cookbook online as one of the resources on the page for the GDL course that you're watching now. Now, this course was put together and it's a fantastic resource. It gives you a lot of information. It gives great examples, and it's one of the best resources to learning GDL in print. So I will include this. You'll notice that it starts from the very beginning and moves through and gets fairly sophisticated. Lots of great information is contained in here. So do download this. And again, I highly recommend that you take the time to have it printed so that you can read in it, make notes, and otherwise make this the valuable resource that it is. So those are 2 excellent resources that you're going to want to use. Now, we wrote this simple program, and which brings us to an understanding of how programs work. So there's a flow to a program. In a program, each line is written and then executed, or it is read and then executed. So the first thing this program does is draw a line from 0, 0 to A, 0. And ArchiCAD is using a right-hand coordinate system where X is in the horizontal direction, Y is in plan, is the vertical direction, and Z is the elevation. If you go to your object and you hit the 2D symbol view, the 3D view, this is probably the best place to see it. This is going to give you a preview of what you've modeled. Now, we haven't modeled anything in 3D, but it does show you that we have a right-hand coordinate system, X, Y, and Z. And we'll get into this more and more as we delve deeper into GDL programming. Now here, is the rectangle preview of the 2D view, X and Y axes. So these are always available for you to take a look at, and you can keep them up here as tabs if you want. So we don't have anything in the master, so nothing is being executed. So this script is looked at by the GDL interpreter and says, there's nothing there. Then it goes, if we're in a 2D view, then it goes directly to the 2D view and starts to perform these commands. And it does them sequentially. And when it comes to the end, it stops the program, and we're left with 4 lines that create the rectangle. Similarly, we can create a 3D object. Let's go ahead and do that now. So the simple 3D object is called block. We can go A, B, ZZY, DX. And this creates a block, Control S. I'll also do a preview. So this creates a block starting at the corner of the block, and we give it the 3 principal coordinates. So it's X or A, Y or B, Z or ZZY, ZX. And because these were the default values used in this program, we're getting a box that's 1 foot cubed. Now, if I Control S to save that and go into the 2D, I can find, when I create a selection view, I double click. Here are the parameters: 1 foot tall, ZZYZX, object height, and I'll put so it's 2 by 3 by 1 foot. Now it looks like that is the orientation. So 2 wide, 3 deep, and 1 foot tall. We go to the 2D view, we can see we have the same thing. So sometimes what I actually do is I'll create a slab for reference, turn off the cover fill, and I show my object in conjunction then, and we'll set it underneath our object. Set this at 0. That gives us some context. So now we know that yes, the A dimension is correct because it's the narrow dimension, and the depth is in the correct direction as well. We can also measure 1 foot, 2 foot, 3 foot. So our object's working very well. I'm going to close these windows. This one. So now we've created the most simple object, which is just a block with an outline in 2D. And we can move this outline in 2D. You'll see that that is moving the object in 3D as well. And this is one of the most powerful parts of ArchiCAD, is recognizing that we often want a symbolic view of an object coupled with a 3-dimensional representation. There is also a way to do a projection, which I'll show you later, so that the 2D view for complicated objects is created automatically. But in general, it's better to directly control the 2D view through coding. Now let's look at how to create multiple elements, because ultimately ArchiCAD has a wide range of ways of creating both 2D elements and 3D elements, but we have to move around to create multiple objects. And when I say move around, these are called transforms. So what I'm going to do here is I'm going to use a command called add x, and I'm going to go to feet. Just going to program that offset. And I'll show you what this means. I'm going to copy and paste. So now we're going to have 2 blocks. Save this. And now we'll look at the 3D. We have 2 blocks here. And the first block is exactly 2 feet away from the original insertion point. If I make the width narrower, you'll see that it's controlling both of them. The first block starts with this being 0, 0, creates a 1 foot wide block. And after that block's created, it moves the origin in the X direction 2 feet to here and creates another block. So what if we wanted the second block to not be a fixed value, but we wanted it to have a parameter? Spacing X, which is a distance. And we're going to default it at 3. Now we'll go into our program, and instead of putting an explicit value, we're going to put the variable. So when ArchiCAD interprets this, it's going to notice that we want to move our origin, and it's going to look to the next parameter, which is a variable, read that parameter, move the origin, and then create another block. So let's save that, Control S. Go to 3D, and here we have 2 blocks. If we open up the parameters, that's now a variable. Now what about our 2D? Because we're only seeing one rectangle in 2D. That's because we only told it to draw one rectangle. So we're going to do the same thing. This time, we're going to use a different command. Now I often forget what the command is for a rectangle. REC or RECT. So I'm going to my book, or I could go to my GDL reference here. I look through the 2D commands. So these are 3D shapes. This is why it's nice to have this printed. And it's rect2 is the command. If I click here, it's going to take me to the description. Here's the description of the line 2, x1, y1 to x2, y2. Gives us a little diagram of what that is, and it's going to do the same thing with the rectangle. Now with that information, 0, 0, A, B, save. And it didn't work, which is a common experience because there's so many little things that go wrong here. So I'm going to go to the 2D transforms. I'll notice that there isn't an add x, but there is an add 2 and an x and a y. So again, and this is something, even if I've done this for over 15 years and I still make these little mistakes because I'm not doing this every day. So don't be disappointed. It's just part of the process. So the format is actually add to spacing x comma 0. Now I hit save. I have two boxes and they're related to the same parameters. So it's going to work perfectly. This is why it's so important to have the reference guides available, because you just can't remember all of these. I am constantly referring to these guides. Now I know that I can do a control C here and a control there. Save that again, control S. I get the same effect, but it's a much simpler to understand code. So this is my preference. I'll tighten that up. So here I'm going to comment, and this is going to draw the outline of two boxes. So anytime you have an exclamation point, any text that follows is going to be what's called commented out. And the interpreter, as it's running this program, will actually just ignore it. But it's a great way to document your file, because when you go back and look at these scripts 2 weeks later, even a couple days later, never quite as clear as when you created it. So it's really important to make sure that you document all of your commands in a very detailed manner. You'll thank yourself later. I'll go to the Control C, C, model two boxes. Doesn't affect the way the program functions, but it does help you understand it. Now let's take the same basic program and do some modifications. Now here we'll notice that I can't control the A dimension anymore, because that A dimension is controlled by my parameters. However, another way, if we were only going to allow two boxes, it might be interesting to eliminate the spacing parameter. I'm just going to turn it off. Won't get rid of it right now. But then I'm going to dereference it. So let's look at what that means. I'm not going to use the spacing X anymore in code. I'm going to pretend that that doesn't exist. So to start with, I'm just going to set it to 0, and that'll just draw one box over the other. However, what I have in mind, draw it in plan here, is to have two boxes. I can control the width of the box, which is still going to be, which is not going to be A anymore. And I'm going to actually call it the width. And then I'm going to make this other box finish at the A dimension. So the width of the group is now going to be A. We're going to go into the object, and I'm going to have an A and a B. But here, let's take this. I'm going to go box X. So it's the X dimension of the box. Width. But let's see what happens. So now, because the spacing is 0, it's just creating two boxes on top of each other. So I can't see the other one. Now I'm going to go back to my 2D script, and I'm going to go A minus box X. Save. So what is it doing? And this is a very typical way of programming where you try something, you get a puzzling result, and then you realize what you did, you correct it. So don't be embarrassed by that. It's just a process. This is box X. Box X. So I'm feeding in now not A, but the width of the box. Now as I control the width of the entire object, it's placing a box at 0 and a box at the A dimension. So it's important to understand how you want the object to perform. What happens when we get too small? Then the boxes overlap. Set the A to a larger number. Later in another video, I'll show you how to actually control what the max and min values are for a particular variable. But this is a good example of how you might take the same type of object and make it work a different way. Similarly, we would go into the 3D script and we go A minus box. I'm going to control this and replace the A. When I go into 3D, I have the same way of maneuvering this object, and I can control the width using the pet palette. So I can also you'll see the power of GDL because all of a sudden we're able to do fairly sophisticated things, graphical interface, accurate dimensions, a 2D view and a 3D view, and all we've written is a few lines of code. So these are the transforms. Let's look at those a little bit more. The transforms end up becoming a really important aspect of GDL. So in the 2D, we can move our origin in the XY plane. We can do a multiplication, which is a scaling factor. And we can also rotate our coordinate system. We're not going to get into the details of this in this video because this is a fairly complex and important topic that needs to be addressed independently. Now in 3D, we can move in just the X, Y, and Z. We can do a single command that allows us to move 3 directions or 3 of the axes in the same command. We have the multiplication or the scaling in the XYZ. Again, we have a composite approach where we can do all 3 one line. We can rotate about the X axis, the Y axis, and the Z axis. We also have a rotation command that allows us to rotate around a vector. So you define your vector X, Y, Z, and then you determine the number of degrees. A fairly complicated way of doing a rotation, so I'd be careful of that. And then you have the matrix form of the transformation, which is a very complete approach, but can be a little bit complicated if you're not familiar with it. Now, the last thing I want to talk about with the transforms is you can move the origin from one place to another, but then you may want to move back to where you started. If you use the del top, it'll revert you back to the initial 0, 0 or the global position. If you just do del and then a number, it'll just take the number of steps back. So let's take a look at this and see how we can use this before we get into a specific approach. Now, I am going to do a del 1. This del1 essentially takes away this x transform. I'm going to do add z 2 feet. If you don't put the foot or the inch symbol, it's going to default as meters. I'm going to draw another block. And let's see what that does. I'm just going to use the 3D view. Actually, that's a little complicated because of the way we've done it. So let's look at the 3D. So we drew a block. We moved over so that this edge aligns with the A value. We deleted that transformation, which put us back here. Then we moved up 2. Let's see what happens if we eliminate that del1. Press to save. Go back to 3D. So now we drew a box. We moved our origin. Drew another box. We moved up 2 feet. We drew another box. Very different experience. So you need to keep track of where your origin is. Often a good practice to do a del top every once in a while, which gets you back to your 0, 0. So you don't have to keep track of exactly how all of those transformations happened. So this gives us enough information in the approach to do our first project. Our first project is to model this table. So how do we approach this? Well, even though this doesn't look like a bunch of blocks, in fact it is. We have 4 legs, 4 aprons, and 1 top. We have 4 plus 4 is 8 plus 1, 9 blocks. And all we need to do is, starting at our origin down here, move to the appropriate location, create a block, move to our next location, create a block, create a block, create a block, until we've created all 9 blocks. Now the trick is, how do you know where to go? And this is going to be what you're going to figure out in this exercise. Now after you do this exercise, the next one will be to create this fence panel. Again, this is just a series of blocks. The only thing that's different about this is that you're going to put in a parameter for the distance of the panel, and then you're going to have to determine the number of pickets and their required spacing. We'll also have a checkbox that allows us to determine if we're going to have a post or not. So if you do 4 in a series, then you only need the post once on the far end. So these are the 2 projects that I'd like you to try on your own. I will create videos that give my approach to solving these problems. I hope you have fun and have a good time.